Hi and welcome to Rigging Vehicles with Rigid Body Physics in Blender. In this class, you're going to learn how to turn static 3D vehicle models into believable physics-driven machines using Blender's rigid body system. My name is Ken and I've been using and teaching Blender for several years now, and I love sharing the skills I've learned over time by publishing classes and tutorials like this one. Now, in this class, we'll start with the foundations, how rigid body physics actually works. Then we'll build things up from there step by step with small, focused mini rigs like a motorized wheel and a working shock absorber. From there, we'll combine everything into a fully rigged dumper truck, complete with suspension, steering, and realistic motion. Now you might be wondering, who is this class for? This class is for 3D artists who want their car models to move realistically, Blender users who are curious about physics simulations but are unsure where to start, or anyone interested in mechanical rigs, vehicles, or real-world motion. You don't need any rigging experience, just a basic understanding of Blender's UI. If you know your way around Blender, you're good to go. By the end of this class, you'll be able to do the following. You'll be able to confidently use active and passive rigid bodies, understand how to control your rigid bodies with rigid body constraints, rig wheels, axles, steering systems, and suspension, test, debug, and polish a complete physics-driven vehicle rig. And all you need is Blender and some curiosity for how things move. So if you've always wanted to make your vehicle models drivable inside your Blender 3D scene, if you've always wanted to be able to export that as an animation, then this is a class for you. Let's get started. Here we are inside Blender, and as you can see, this is a brand new Blender installation. This is the default view that you should have on your screen right now. So I'm just going to get rid of the light and the default camera, and I'm going to use the default cube because in this lesson we want to have a quick overview of the rigid body physics system. We just want to look around and see what's there, just to familiarize ourselves with the main concepts we need to understand. So while we have this cube selected, I want to make it flat. So I'm going to hit S on the keyboard, S, and then Z to constrain it to the Z axis so that we're resizing it only in the Z. And then I'm going to hit S and then Shift Z to scale it in all axes except the Z axis. So Shift Z, maybe up to that point. I'm going to Shift A and add a cube, G, Z. Let me just place it up there. So now that we have these two objects, we're ready to apply the rigid body physics system to them and start understanding what's happening. So let me start by clicking this, and if we hover over this properties area, we're going to see the physics properties tab. So I'm going to click that, and we have different physics systems here. I'm going to go to the rigid body. So when I click this, now that applies this rigid body to this plane. I'm going to do the same for this cube, and because we're in the physics properties, we can go to rigid body, and now both of them are rigid bodies. Now if I click the space bar, if I press the space bar, both of them fall off, and if I rotate, they're still falling off because Blender has gravity, and the moment we play the timeline down here, the objects fall off until the end of the simulation. And so the big question is, how do we make things stay where they are? How do we suspend them in the air? If I select this flat ground, now let me call it the ground. If I select that and go to the rigid body, I need to make it a passive type of body. Now that means, or that tells Blender, hey, this particular object here should not move. It should stay where it is. When I select this, we will leave it as an active object. That tells Blender this object should be acted upon by physics. And so if I now play, it falls on this ground that is not supposed to move because the type of this rigid body is now passive. Do not move, passive. Those are the two first concepts you need to understand when you're working with rigid bodies. If you want a ground, a landscape, a floor, a suspended platform that does not fall through because of gravity, apply a passive type of rigid body. And the other one that is going to have physics act on it, for example, Shift D. Now we have two. If I select both of them, G, Z, and go back to the first frame, play. Now both, let me just push this GX. If I go back to the start, now because of physics, let me push this GZ. If I play, because these are active rigid bodies, physics will apply or act on them. They will behave like real physical objects. Now, those are just two concepts I wanted us to get as we get started. In the next lesson, I want us to look at these options right here so we can understand how they affect what we're about to build. So I'll see you shortly. And welcome back. So now in this lesson, we want to do a few things. Number one, we want to understand some of these options here, but we're not going to look at all the various options available to the rigid body system. We're only going to look at the ones that are relevant to our task in this class. So before we move further, we want to look at this shape right here. These are now already active rigid bodies. And if I select this and duplicate it, Shift D, Z, and place it above there. And let me select this and make it bigger. So S twice, maybe S in the X axis, because I want it slightly bigger than this one. And now if I rotate this, rotate it in the Y axis so that it's slightly leaning, or maybe rotate further, just like that. Now I want to go back to the very beginning, and then I want to have those two selected, then G, Z. I want the animation to start from here. I want them to fall on this, G, X. And if I play that, now as you can see, they're falling like boxes. Let's see that again. Yeah, they're falling like boxes. Now, if I go here to this shape option, let's say, I think this is the one selected. Let me select this one. We're now acting on the rigid body applied to this one specifically. Now, if I go here and choose cylinder and go back here to the very beginning, and let me rotate it. As you can see, first of all, when we applied the cylinder shape to it, inside, if I switch to this wireframe view, you notice we have this cylinder. And this cylinder shape is what the rigid body system sees as the shape that's rotating when it's falling off of this plane. So if we play that, Blender and this rigid body system sees the rotating object, the ghost that's rotating, as this cylinder. And so if we go back here to the beginning, and let me rotate this in the X 90 degrees, so that the cylinder ghost is now positioned in a way that it can rotate. Let's watch what happens now. As you can see, if I go back to solid view, the cube is sinking. The mesh of the cube is sinking, but the ghost is what's actually rotating on this shape. So that tells us it's very important to choose the specific shape you want for the body or the mesh you want to apply rigid body animations to or simulations to, because it might not behave as you expect it to if you have the wrong shape. Now I bring this up because in this lesson we're going to be creating a simple spinning wheel, and if it's a wheel we will have to choose a cylinder shape, but we're going to get to that. Before we get to that, let's have a look at the rest of these shapes. So let me apply a cone shape to this, and let's look at what it has inside. So if we go back to the beginning, how will it behave? Pause it right there, and let's switch back to solid. As you can see, it's sinking because Blender sees the cone shape as the shape that should be rotating, and so the mesh just sinks through the platform. But now if we choose a box and go back to the beginning and play it, it doesn't sink. So let me just go back here and GY to put it aside. Then let's see them both. This is sinking, but this is not sinking, as you can see, because of the shape. That's very important. These others, let me show you surface responses. For example, bounciness. We can make objects bouncy going back to the very first frame. Let's play. I think we need to make this bouncy as well. So selecting this and making it bouncy. Now let's play it. Both are bouncy. About one. And this one, bounciness of 1. Yes, as you can see, it's much more bouncy than this other one. So as we continue working on our tasks, we're going to interact with some of these properties, and you're going to learn what they do. So now I think this is a good spot to end this lesson, because I just wanted us to have a quick look at that specific property, because it's very important to what we're trying to achieve. With that, in the next lesson, let's now work on our simple spinning wheel. I'll see you shortly. I think we're ready to start building our wheel. So now what I'm going to do is select these and just delete them. Now we're left with this flat surface. I want to Shift A, add a cylinder. I'll hit S to scale it in the Z axis. So hit Z, then 0.5, make it half the height. Now Z, I want to put it up here, and I'm going to Control A and apply all transforms. Then I'm going to right click, set origin, place the origin in the middle of the geometry. So right there. Now with this cylinder selected, I want to apply a rigid body to it, and it's an active body. This is going to be our passive body. Remember, we already made it a passive body. Now going to this active, but for this we're going to apply cylinder. Very important, and we already saw why. But before we do anything else, I want to rotate it along the x-axis. R in the X, it should rotate 90 degrees to be upright like a wheel. Now if I drag this to the beginning and hit play, nothing happens. It's just a wheel. And so we played it, it's not playing. And the reason is because we need a way to tell Blender hey, spin this cylinder in this axis or along this axis and at this speed, because every wheel needs a way to spin faster or slower. You need a way to speed up or slow down. How do you do that? We use what we call constraints. Constraints are the way you control your rigid body in Blender. So if you want to tell an object that has a rigid body applied to it, rotate like this, or move like this, or scale up to double size, you use what we call constraints. How do we apply a constraint to this wheel? First of all, we need, let's first of all push it to the left or to the right. G, Y, let me just place it right there on the side. And I want to add a cube. In fact, let me just make it very small. G, Z. Now, the reason I'm adding this cube is because I want to add the constraint between it and the wheel. Because what we're doing is essentially applying a constraint between two objects, two rigid bodies. How should this wheel behave in relation to this cube? And how should this cube behave in relation to this wheel? When we put a constraint between them, or if we connect them with a constraint, now the constraint can tell the wheel how to behave. So because we have the two of them, first of all, I want to apply the transforms as usual. Always apply your transforms. Control A to the cube. All transforms, and now the origin has moved to the world origin. I want to right click, set origin to geometry. Now it's right there. Our wheel is awesome. So now I'm going to select the cube and also make it a rigid body, and just let me make it passive. I just don't want it to move, so it's going to remain there. And I'm going to select the wheel, so both of them are selected, and I'm going to go to object, rigid body, connect. Now we've connected the two of them. If I select this, this is the constraint we've applied, and this is what it looks like. When I select it, automatically this changes to rigid body constraint. And the automatic type selected here is fixed, but what we want is to move this wheel, to power this wheel. So if we look at the drop down here, the best solution for us is a motor constraint. So select motor, and now what we need to do is select angular. That enables the rotation. Now we're going to have to rotate this in order for the axis to be right, because the wheel will rotate in the x-axis. When we enable this angular motor right here, it applies to the x-axis. So if I hit play, spacebar, as you can see, nothing happens. Now let me rotate this, rotate in the Z 90 degrees, negative or positive, it doesn't really matter. Now let me play. As you can see, now it's rotating, because this constraint has to be oriented in a way that this x-axis is in line with the axis that this should rotate in. Now, another thing we need to do is, let me go back here to the very beginning, select the constraint, and if I switch to the side, now to the front, and Alt Z to make it transparent, as you can see, the constraint is not positioned at the center of the wheel. If the wheel is to spin accurately, we need this constraint to be in the center, because this spins in relation to where this is positioned, where the constraint is. So I'm going to select the constraint and then select the wheel last, so both of them are selected. Then go to object, snap selection to active. So snap this selection to active. The last item you select in the 3D viewport is the active. So selection to active. Now we put it smack in the middle of the wheel. Alt Z to toggle transparency. Now if I hit play, now the wheel is free to move. But the question is, how do I speed it up or slow it down? So what we do is go back to the constraint, because remember, we say the reason we want to add a constraint is because we need a way to tell Blender spin this object this fast, or slow down to this degree, or scale up this model to this size. So constraints are what allow us to define the constraints, the limits. So if I select this and go back here, we can use this target velocity as the acceleration. So let me just go back here and play. If I move to the negative, it will start moving in the opposite direction, as you can see. All right, I want to make this longer, this timeline. So let me just add a 1 here to 1250. And now, even though I've added the frames to 1250, it will still simulate up to 250. Let me just show you. Let me go to the positive to push it forward. Now, as you can see, it got to 250 and just froze because there is no more simulation here. And to change that, what we do is go to the, I think, scene, rigid body world. Let's go to the cache and simulation start and end. Let's add that 1 here. So now the simulation length is determined by these values here, not these ones here. So now if I play this, it will continue simulating as long as this is running up to here. Now it's heading in the opposite, and we have our rigid body constraint here. Let me go to our constraints and move with the negative. Let me just start here again. Play. Let me just start at 1. Play. Now if I move in the positive, it moves faster, but very slowly. If we want this target velocity to be more responsive, we can do that with this. So if I say 10 here, maximum impulse, how impulsive is this? So now if I go back here and play, if I go in the positive, as you can see, it's moving faster. All right, slow down. Very drastic. Play again. Now we're moving in the opposite direction. If I change this to the positive, let's start moving in the positive direction. If I move too fast, it starts skidding, as you can see, because it's too slippery. And if we want to solve that slipperiness, all we have to do is select the surface. Because it's a rigid body, now let's go to the rigid body settings it has. Then let's go to the surface response. Let's increase the friction to maybe 0.76. Let's also select the wheel itself, and let's go to its surface response and also 0.75. Now we've increased the friction between the two. If I go back in here, zoom in, select the constraint. Let me start at 1 and then play. If I accelerate quickly, now there is no more skidding. It just loses control, but there is no more skidding. Let's go. Slow down. Move in the opposite direction. Slow down. move in the positive direction. Slow down. So if we reduce this to 1, it becomes less responsive. As you can see, I need to drag this very far in order for the wheel to respond. As you can see, I'm already at positive 17 and it still was moving backwards. All right, now if I switch to negative 20, it's still moving towards the negative side, positive side, and I'm at negative. So if we increase this, all right, let me just pause that. Slow down. As you can see, it's very responsive. I'm showing you these things because this is the constraint you will use to control the vehicle. So understanding what's happening is very crucial. So now that we have a spinning wheel, I think we're ready to move on to the next crucial part of a rigged car: suspension, shock absorbers. How do we create them? Let's see how to do that in the next lesson. See you shortly. So now it's time to see how to create a simple shock absorber. So let me just place that back there. Select this, Shift D, because all I want to do is create a platform like that. And I'm just going to S twice to scale it down, maybe up to that spot. And while this is still selected, I'm going to change this to active. This is what we're going to apply the shock absorber to. And the shock absorber is going to be in relation to the ground, not the wheel. We're just looking at an example. So while this is selected, I'll select the ground. Now we have those two. We want to use another constraint. So let's go here, Object, Rigid Body, Connect. And now we have a constraint right here between them. As usual, the type by default is fixed, but what we want is what we call a generic spring. When we add it, we have these different fields here, but the ones we want to work with are the limits, which have the angular and linear fields. So if I collapse limits, the other one that we want is springs, which has angular and linear as well. So limits and springs. Let's start with the limits. This is to limit what side or what axis this platform or object can rotate in or transform in. So because it's a spring, let me just go back to selecting the constraint. For now, we don't want it to rotate it in, we don't want it to wobble in any direction. We don't want it to wobble in the x-axis, y-axis. We just want to limit it. So I'm going to check these 3 boxes and then set that to 0. That says limit the rotation, the angular rotation of this object in the x-axis to 0, in the y-axis to 0, and in the z-axis to 0. It should not rotate in any direction. Then linear, of course, is up and down. We want to limit, we don't want it to move to the left, to the x, or in the y, but we want it to move in the z. So we don't want to limit it in the z, therefore we're not going to check that box. Now let's go and expand the springs. The springs section has the same fields, but the field we're interested in is, because remember, here we're setting limits. Let's limit all these. But here we're setting the springiness. So if we enable this, we're saying let it be springy in this axis, the z-axis. Stiffness, how stiff should it be? Let's give it maybe 150. Let's give this damping 1, and I'll show you what that does. And down here in the linear section, let's also enable the z-axis. Let's say maybe 150, could also be 160, doesn't really matter. I'll give it 150 and 1. So now if I play, as you can see, it's suspended in the air and it's bouncing around. Now damping means if I play again, let's first of all make it less constrained, less stiff. Let's just give it a stiffness of 50. If I play it again, as you can see, it's springy and the springiness dies down slowly with time. So damping means how much should this object continue springing afterwards. Right now it's still continuing. If we increase this number to 10, it stops springing very soon. As you can see, let me just change this to 10 as well. Now let's play that. As you can see, it doesn't continue springing. If we make this maybe 2 and this 2, let's see what happens. Yeah. So now let me pick this wheel. Let's go back to the beginning. G, Z, and place it here in the air. And just play and see what will happen. And we have ourselves a shock absorber. Once again. So this is the same principle we're going to apply to our vehicle rig in order for the vehicle to act like it has shock absorbers. And when it interacts with other objects, it's going to spring like that. When you hit bumps, it's going to be able to spring like that. So I think this is a safe spot to end this lesson. We've seen how to make a nice shock absorber. Now I think we're ready to start creating our actual collision shapes, the ones we're going to use as our rig. And welcome back. So now we're ready to start working on the actual rig. And as you can see, I have this sample damper track here. And I want to use this as an example to show you how to organize your vehicle model. So as you can see right here in my outliner, I have a collection called damper track. So the entire model here is a collection, but it's a collection of all these different objects. So it's a collection called damper track. And in the collection, we have just two things. We have two collections, wheels and the chassis. So now, if I hide the chassis, we have wheels. We have, let me just expand the wheels. We have wheels rear, of course here, and wheels front. Now, if I expand the wheels rear, as you can see, we have left, wheels rear, left, wheels rear, right. Now, if I hide L, as you can see, hide right. Let me collapse the wheels rear, expand front, left, right. Collapse the wheels, expand the chassis, and let me just make it visible. Hide the wheels. Now the wheels are hidden. Let me just toggle them. So they're hidden. This is what we call the chassis in this rigging system we're creating. We just want to have this entire thing as one whole collection. Of course, mine is several different objects, but you can model yours to be just one whole object. Or if you have several objects, side mirrors, seats, windscreens, you can put them all in one collection and just call them the chassis. As you can see right here on my chassis, we have the dump frame. I just call this the dump frame. Let me hide it. We have the cockpit and we have the tipping bed, because this is a damper truck. So I just gave them those names, but we will not use them individually because they all count as the chassis, and that's all that counts. We will use only these two to create our rig. Now, another thing we need to keep in mind is applying transforms. You will notice if I click any object, the origin is at its center. So no matter what I click, its origin is at its center. And that's very important. So the way to do that is simply to switch to any orthographic view, maybe that view, select all the objects, go to object, set origin to geometry. That will put each object's origin at its center. And that's very important because when the car is moving around in the 3D viewport, it's going to be moving around based on its origin in relation to the world origin. So the relationship between the world origin and the origin of this object will make it behave accurately in the 3D world. So that's why we have to make sure, once again, every object has its origin at its center. Let me just hit the / to zoom in on that. This is what it means to have the origin at the center. / again to move out of isolation. So I think now we're ready to move on to the next lesson. Let's now start creating the collision shapes that will define our rig. So I'll see you shortly. And welcome back. It's time for us to create the collision shapes. In other words, the rigid bodies. They're also called collision shapes because they're the ones colliding in the physics world. One thing I need to mention about the way I model vehicles is if I switch to the side view, I always make sure my wheels are placed symmetrically in relation to the origin, to the world origin. That makes it very easy for me to mirror my wheels in the 4 spots. I shared a time-lapse video of me modeling this, showing you exactly how I was able to place those wheels symmetrically, equally. And what that allows us to do is, let me just start here. Shift A. Let's place a cylinder here. And of course, as usual, SZ 0.5 to reduce the size. And while it's still there, I'm going to apply a rigid body and make it active. Then I'm going to change this to a cylinder. Control A, apply all transforms. Set origin to geometry. Rotating the Y 90 degrees. Then while it's still selected, I'm going to shift select the rim here of the wheel. Go to object, snap selection to active. Snap this selection to active, to the last selected. So it's going to place it smack in the middle. Now I can click away, then click this S twice to scale it down to maybe that spot. SX, maybe up to that spot, because I want it to be the ghost of our wheel, because this is the collision shape. This is what the physics is going to be acting on. It's not going to be acting on the actual tires. We're going to parent the tires to the collision shapes. And so what the collision shapes do, the tires do. So that's why we want to make sure the collision shape is almost the same exact size as one of the wheels. So now the reason I was saying it's important to make this symmetrical is because if I go to the modifiers and add a mirror modifier, apply it to the Y and X, and Control A to apply all transforms. That's just to return the origin to the center. Apply all transforms. Now that just mirrors this collision shape across the 4 axes. If I disable this, as you can see, it's only mirrored it across. Don't worry about this, I'll tell you what this is. But now it's mirrored it across. And if I add the y-axis, this is the y-axis, we're going to mirror these two across to the front. So y. And because these tires or wheels were modeled symmetrical, as you can see, I'm able to mirror them very easily. So when you're modeling, always remember to make your wheels symmetrical. Base your vehicle on where the wheels are placed. So now this here is actually the physics rigid body. And there are actually 4 rigid bodies, one for each of these. So now what I want to do first of all is apply this modifier. So go back to modifiers and apply that. Then I'll switch to edit mode while they are still selected, because now they're one object. Tab. While all of them are selected, I'm going to right click one of them and go to separate by loose parts. Now each of them is its own individual object. Previously they were one object. So now if I tab out, I can select this or this. Now the reason we have all their collision shapes over there is because the origins are in the world origin. So I need to right click here, set origin to geometry. Now you see that brings that there. Select this, right click to geometry, select this, right click to geometry, and finally there. So now I'll just pick this one, enter into tab mode, select all, say A, rotate in the Y 90 degrees. Tab out of edit mode, rotate in the Y again now, and now we've gotten rid of that confusion there. So let me just select this as well, enter into edit mode with tab A to select all the vertices and faces, then rotate in the Y 90 degrees, then tab to object mode, rotate in the Y 90 degrees. Do the same for this. Edit mode, A to select all faces, RY 90 degrees. At this moment, I'm going to hide the track because we don't need it. We just wanted it to know exactly where the wheels are. Right now, we're not going to need it for quite some time. We're going to show it later. So right now, the next thing I want to do is, all right, before we hide it completely, I want to add a cube. Switch to the side view, GZ. I want to create a sort of platform or frame, SY, GY, GZ. I want to place it right there. So I want to have a platform that represents the chassis, and that's what's going to represent the chassis. So now let me just push it down, GZ, SX, GZ. So now this is going to represent the chassis when we hide it like that. We just want those. Now this is not yet a physics object, so let's go to physics and make it a rigid body, and it should also be active. Let's give it a mesh shape. That just means the collision shape should be exactly the way the mesh is shaped. So with that, let's now add some shock absorbers to the rear wheels, because in this lesson we're working on rear wheels. Or I think this lesson has now become too long. I think we should not make this lesson too long. We just finished preparing the collision shapes. In the next lesson, let's now add suspension or shock absorbers to the rear axle. I'll see you shortly. And welcome back. So now it's time to add suspension or shock absorbers to our rear axle. So how do we add shock absorbers? We already saw that. We use a generic spring constraint. So we're going to select the chassis and the wheel, one of the wheels. Then I'm going to go to Object, Rigid Body, Connect. So now we have a constraint. Let me just shrink it down. And now remember, we want it to be smack in the middle of the wheel in order for the wheel to rotate naturally. So while it's still selected, I'll hold down Shift and select the wheel itself, go to Object, Snap to Active. So now it's in the middle of the wheel. If I switch to the side with 3 on the numpad, it's in the middle. I'm going to do the same for this other wheel. Select the body or chassis, then this other wheel, Object, Rigid Body, Connect, and there we have our constraint. Select it, shrink it down. While it's still selected, hold down Shift, select that, Object, Snap to Active. Now I want to switch to 3 so I can size these properly. I like using orthographic view like this, S. And now I can just align them, but I like offsetting one of them to make it easy for me to select them from this view. So now we have our 2 constraints, but of course, remember, by default, if I select this constraint, the type here is fixed. We want to change that to generic spring. For the angular limit, we want to limit its rotation in the Y and Z axis, but we want it to rotate in the X. Remember, if I switch to the front and then rotate, it's a best practice to make your cars oriented in the Y axis, heading in this direction. And so the wheel should be rotating around the X axis. It should be spinning along the X axis. And that's why our constraint here has this X axis. So we don't want to limit that rotation. We want to allow the rotation. So we should not check this limitation, but we want to limit the Y and X axis and Z axis. Now, when it comes to the linear movement, we want to allow up and down movement. So that's the Z axis. We want to limit these other 2 to 0. We can just leave the other one like that. Let's go down to springs. How springy do we want it to be? Let's go and set this to maybe 100 and set this to 1. Let's go down here to the linear, 100, and set this as 1. So if I hit play, wait, we don't have a platform. So let me just go back to the beginning here and Shift A. Let's add a plane. Let's just size it. I'll hit S, then 10 to scale it 10 times. Then while it's still selected, I'll go to rigid body and make it the passive object here. So now it's going to remain suspended in the air. If I hit play, there we go. So now going back here, let's now switch to this other constraint, because let me just play this. As you can see, it's suspended here. on this side. Let me apply a spring on this other one. So selecting this, I'll change this to generic spring. As usual, we don't want to limit it in the X, but limit it in these 0. We want to limit these to 0, and down here we want to allow it to move a little bit. Just like that. Now if we start again, as you can see, the rear axle is now springy. Let's start again. Let me hide these two. 1. And play this. All right, so let's do the same for these the front axles, but this is not the way we're going to implement them. I just want the front wheels to not be left without any suspension, but we're going to undo all that later. So selecting this, then the wheel, let's add a connection there. Make it smaller. While it's selected, select that. Snap to active. Select this, hold down shift, select that. Connect. Select the constraint, select the wheel, snap to active, then select the constraint, make it smaller. Switch to 3. I think they're good. All right. So while this is selected, change to generic spring. Limit these two. Limit these two. And let's go here. 100. 1. 100. 1. Finally, let's go here. Let's limit these two. We should also limit these. One 100. 1. 100. 1. Enable. Let me just confirm this one is properly set. All right, so now if we play that, all right, there we go. So now don't worry about the wobbliness. We're going to sort that out, but at least right now we have both the front and rear axles working. Now let's increase the stiffness a little bit to let's make it 300 to reduce the springiness. 300. Let's also do the same for this. 300. 300. 300, and here 300. I think I forgot one here. Let's go now. Yeah. There we go. If I select this and rotate it slightly in the X, and then play again from the start. Let's play again. Don't worry about that. We're going to sort it out. So I think this is a nice place to end this lesson. in the next lesson, let's now start working on the front axle because it's going to be different. Remember, we have to account not just for the suspension and the spinning of the wheel, but also the steering. How do we account for that? Let's see how to do that in the next lesson. See you shortly. So now it's time to work on the front axle and the steering system. Now, we already have spinning front wheels, so that's not a problem. That's actually a good thing. Now, I want to zoom in on this front left wheel right here. Currently, the wheel can only rotate along the x-axis, but we want it to also rotate along this axis so that it's able to turn left and right. So it needs to rotate along this up-down axis. But these constraints only rotate along the x-axis. So that means we need to have a constraint that's rotated in this manner. Rotate y 90 degrees, let's say negative 90 degrees. So we need the x up there, and that will mean the wheel can rotate left and right. Let me just undo that. That was just an example. So what we want to do is have a small disc right here in the inner side of the front wheel, and the role that small disc is going to play is it's going to be the attachment of the wheel to the chassis. We're going to attach the chassis to that small disc and then attach the wheel to that small disc. We can then add the constraint I've described with the x-axis facing up, and that disc will be able to move left and right, to rotate left and right. And when it rotates left and right, that means the wheel which is attached to it is also going to rotate left and right. I hope you're understanding that. So that's the mechanism we want to create. So I'm going to select the wheel itself, Shift D, X to move it in the x-axis, and then I'm going to S twice to just make it smaller. Switch to the front, SS, then let's say GX. I want to bring it closer here, right there. So we have that small disc. Of course, I'm going to mirror it to the other side. Let me just do that. Mirror in the X, but now it's going to require me to do all those transform and apply transforms again, and I don't really want that. All right, let's just do it. So let me just apply transforms, and now it's reflected to this side. Let me apply that mirror modifier. Then in here, I'm going to hit tab, right click, separate by loose parts, then tab, select this, right click, origin to geometry, tab to enter into edit mode, all, rotating the Y 90 degrees, tab, object mode, rotating the Y 90 degrees. Same case applies to this, set origin to geometry, tab, all, rotating the Y 90, tab, rotate Y 90. All right, so we have our two discs. And this disc actually, because we just duplicated this wheel, has all the rigid body properties the wheel had. So we don't need to change anything because it's already, we want it to be an active rigid body. But what we want to do is actually select this chassis, then select the disc. I call it the steering disc, object, rigid body, connect, and now we have a new constraint. Select the constraint, select that, disk, snap to active, and now it's on that. I'm going to select the constraint, shrink it, and I want to rotate it along the Y, -90, to put the X up here. So now that means if we change this to a motor and apply this angular motor, the rotation should happen in a left to right design. But now, right now, if we try to move this, if we play, there's a problem. And that's because this constraint is a motor constraint. We still need to have because remember, the chassis should be attached to the disc, and then the wheel should be attached to the disc. So if there is any suspension, it should be on the disc which is attached to the body. So let me select the body or the chassis, then the disc. Then we also need to go to object. In fact, I can just pick this because we had already applied this as a generic spring. So what I can do is, while it's selected, because I've selected it, go to its properties, and here we have the objects that are assigned to it. As you can see, we have cube, which is this, and the cylinder. So what I want to change is the cylinder it's assigned to this cylinder. So pick this picker, and we're going to have cylinder number 4. So now this constraint belongs to this, not this. While it's selected, I'll select the disk, object, snap to active, just like that. So now we have a constraint that acts as the spring, and we have another constraint that allows the disk to rotate in a left and right design. Now I want to do the same on this other side, but instead of repeating what we just did, I'm just going to take this and of course go back in here and change this to this disk. Then while it's selected and this is selected, I'll go to snap to active. So now that's our suspension. Let's go ahead and take this motor constraint, Shift D, X, and I'm going to select this object, snap to active. But now we don't want it facing up, we want it facing down, because they're going to try to face each other. The two wheels are going to try to face each other, and that's not how vehicles move. We want them to face opposite directions, the same direction. So with this selected, I'm going to say rotate along the Y 180 degrees. So now that just flips it upside down and the X is below. So this is a generic spring, and this is a steering constraint. Now there is still a problem. My seat is sliding down. Now there's still an issue we need to sort out, and let me just show it to you. If I play, yes, we have the suspension, it's right there. But can you guess what the problem is with our car? All right, so if you guess that it's missing the constraint that's supposed to attach the wheel to the disc, then you're right. So we need a way to attach this wheel to the disc. So I'll just select the disc, then the wheel, go to object, let's add a connection. Let's bring this constraint, select that, then snap to active. Let me just shrink it, just like that. While it's selected, we're going to change this to a generic. This time it's not a spring, because the springiness or the shock absorber is right here on the chassis to the wheel, shock absorber, but there should not be any springing between the disc and the wheel. They should be clutching one another and moving at the same time in the same direction without any of them sliding against each other or springing. Like I said, we're going to use a generic, and the difference between a generic and a generic spring is that the generic does not have any springing, but it has limits, because we want to limit the direction that the wheel can rotate in relation to the disc. So we do not want the wheel to rotate in the Y direction, in this direction, or in other words, in this direction. So selecting this constraint again, we do not want it rotating in the Y or the Z axis. The Z axis is, of course, we don't want it rotating in this direction because it's going to be rotated by the disc. It should not rotate itself. When the disc rotates, the wheel rotates. So selecting this again, limit it in that. But we want the wheel to rotate in the X while it's attached to the disc. Rotate in the X, like the rear wheel. Now, there's a problem I introduced earlier that I'm now going to mention. The disc itself should not rotate in the X because it should always remain upright, because its job is to just steer the vehicle. It's not supposed to rotate, spin forward. It's supposed to only rotate left and right. But remember, this here is its constraint, and I've allowed it to spin in the X. That should not be, so I should limit that to 0. So now the only thing that's going to spin is the wheel along the X axis. All right, now this is still selected, the constraint of the wheel. And remember, this is just the generic. We do not want it to move up and down, left and right, in any direction. Remember, this constraint is in relation to the disc. So the wheel should not move up and down, forward and back, left and right in relation to the disc. Now, with that done, I'm going to select that constraint, Shift D, X, and now take it to the other side. Now, while it's still selected, I will go to the objects here, and as you can see, it's attached to this disc and this disc. So I want to cancel those two and say it should be attached to this wheel and that disc. So now, moment of truth. I don't know if it's going to work. Fingers crossed. Let me just cross-check everything. The wheel is allowed to rotate in the X. Now, I don't think we took care of this rotation here. Motor. Cylinder 4. I think this is cylinder 5. Yes, this should be cylinder 5 from the chassis. That's the steering constraint. This constraint, same as this small one in here. So now let's go ahead and play and see what shall happen. So now these are falling. Why? Or we did not limit these Yes, we said limit, but we did not set them to 0. Let me put that at 0. Let's see. Yeah, so let's also set this other side. We forgot to set these to 0 because we do not want them to rotate in the y-axis. So the limit should be 0. In other words, when you hover over this, it says limit rotation around y-axis to 0. So it should not rotate along the y-axis. Right now, it just fell along the y-axis. It tipped over. It should not do that. So now let's play that. There we go. So now, if I select the steering constraint, this constraint, let me give this 10. And if I play it, as you can see, we're able to turn it. But there is a problem. I think we have an issue here. And if I play it, as you can see, we're able to turn it. But there is a problem. I think we have an issue here. And I think I know what the problem might be. Now, if we get closer to the front steering, let's do a quick recap right now to understand our setup and then solve this problem. Because let me just play this once again. If you followed me closely from the beginning up to now, then you have this problem where the wheel is turning independently of the disc. So let me just play that again, and let me just rotate this slightly in the X like that to push the vehicle forward. So if we let it go, as you can see, the disc and the wheel are not aligned. So in fact, the disc is remaining straight, facing forward, the two discs. And these discs are the ones responsible for steering, because as they turn, they should turn the wheel that's attached to them. So going back here, let's now get closer to this and let me show you what the problem is. So remember, this is our suspension or our shock absorber, as well as our steering, because it's on this z-axis that we tell this disc to rotate left and right. And what powers that rotation is this other constraint right here. It's the motor constraint. Remember, the motor constraint just spins a cylinder. It causes a cylinder to spin because the cylinder has no way to know when to spin. You have to use this motor cylinder to give it power, the target velocity. So to power the wheel, to power the steering, we have this constraint, and when we apply a positive value, it turns right. When we apply a negative value, it turns left. But the constraint responsible for limiting how far we can rotate left and right is this constraint right here that has the shock absorber, that has the limits. In short, we're looking for the limits. The limits we set, first of all, are we cannot rotate in the X, in the Y, or in the Z. So this disc should not rotate in the X, rotate in the X. So in the X, it should not rotate. So that's why it's 0. Let me just select it, 0. It should not rotate in the Y, but it should rotate in the Z because we want it to be able to rotate left and right like that. And when it rotates in the Z, because the wheel is attached to it, it should also now rotate. So let's go back here, and the problem lies here then, because we've limited it to 0 instead of allowing it an angle to rotate. So let's say the lower z is negative maybe 35 and the upper is positive 35 degrees. So that allows this disc now to rotate left and right 35 degrees. We're going to select this and do the same. No, this. I don't know why I don't have this limited like that. It should be limited. Yes, this should be 0. And this should be negative 35. And this should be 35. Now, if we play it, as you can see, now they are responsible for rotating the wheels. But now, of course, there's a problem here. The wheels are facing the opposite direction. So what we want to do is, well, this power is selected here. Let's change it to -1. And let's change this other steering motor to +1. When this is negative, this should be positive. And we're talking about the motor constraints. So if we go back here now and play, there we go. So that's one of the problems we wanted to solve. Let me show you another quick problem I noticed while I was debugging that. Number 3. If I played from the side and if you followed me up to this point, there is this problem of the chassis seeming to wobble up and down as it rotates. Let me just power this. I was planning to add the motor constraint in the next lesson. In fact, why don't we do that in the next lesson? I want to show you a second bug, and I think it's best to do it in its own lesson. So I'll see you shortly and I'll show you what bug I'm talking about. So this is exactly where we left off in the previous lesson, and I want to show you the second bug I want us to fix. Now let me just pull this back to the very beginning, expand that just slightly. Now, in order to see this problem more clearly, I'm going to add a motor. I'm going to add a motor constraint to this rear wheel so we can power the vehicle. Right now, we've just been depending on gravity to move the car. But right now, let's go ahead and add the motor. And let's power this. So selecting the cube and the wheel, then go here, rigid. Let's add another constraint. Select the constraint, select the wheel, object, snap selected to active. Then let's just shrink it down. Now it's smack in the middle of the wheel, and the wheel will rotate correctly. But I want to GX and put it right there, close to the edge of this, GX. All right, so there we go. Now we're going to change this constraint to a motor constraint, and remember, when we activate this, the wheel that has the constraint is going to rotate along the x-axis of the constraint, this axis. So now that this is active, what happens when we play? And this is at 1. As you can see, it's powering the wheel. Now let me go ahead and Shift D, X, so I can, oh wait, no, let me delete that. I want to make sure we're properly aligned first. Select that, Shift D, X, and let's place it on the other side. And because this constraint should be applied to this wheel, I need to come here to this cylinder and change it to cylinder 1. So now this is powering this. So if we play, now the two of them are powering the front wheel. But now if we switch to the side and I want to select the steering, here, and put it at 0 to avoid steering it to the right, because 1 is right, -1 is left. Go to this, because I want the car to move in a straight line, 0. Now when we play, it will move in a straight line. Now notice what's happening to this center chassis. If we switch to the side, it seems to be limping or wobbling. Let me just start this, play. Can you see that? So there's a problem there, and that's the bug I was talking about. Now, let's go back here to the very beginning, and I want to show you what the problem is. Now, this is the suspension of this wheel, and this is that wheel's suspension. With this selected, if we go here to the limits, we forgot to set this linear limit right here to 0, and that just tells this wheel, do not move, you're not free to move left and right. That's X, because this is the X axis, so the wheel is not free to move along the X and X axis. Let me go back here. So limits, linear limits, you're not free to move in the Y axis, so you're not free to move linearly, and you're not free to move linearly in the Z axis. But now our problem is, if we go back to the limits here, we did not have this limit. If you check your settings, we had forgotten to set this limit, and what we need to do is have that at 0. That means as the wheel spins, it does not move up and down in the Z axis, because if this is off, let me just select this. If this is not limited, that's why this keeps going up and down, but this is not what is going up and down. It's actually the wheels that are free to move up and down, but because they're placed on a passive rigid body that's not moving, they cannot move up and down. So what we see moving up and down is the suspended chassis, but the problem is that we did not limit the wheels up and down movement, linear movement. So we need to limit that. Let me go to the first frame once again, go back to this other side. Notice here we had not set that limit, set it to 0. Let me check this other one. We had that at 0, and this is at 0 because it's attached to the disc. But now what about the discs, because those are the ones attached to the chassis? We need to do the same here, 0. Then right here, 0. Now you might be wondering, what about the springiness? But remember, this sets the limits. You're not allowed to move in this direction or that direction or rotate in any direction. If it's springiness, we set the springiness in the springs area, and we've already allowed the Z axis on the angular side. They're free to wobble a little bit as they spring, and on the linear side we've allowed it to bounce. So if we play this now, let me switch to the front. Now it's moving in a straight line. Let me just start again. So right now there is no wobbling. It's moving in a straight line, and that's what we want. So I hope you understood exactly what I was talking about. Now these are a little bit confusing, these constraints. in the next lesson, let's now start labeling them and organizing our collision shapes, because this should be a reusable rigging system. So I'll see you shortly. Don't go anywhere. So now it's time to rename and organize our constraints as well as our collision shapes. So I think we should start with the collision shapes. So first of all, I select that, and that, because those are our collision shapes, and also the disks. Then I'll press M for new collection, say new collection here, and I'll call them collision shapes. Enter again. So now we have a collection of collision shapes, a collection of the model, the dumper truck, and we want to create a collection of the constraints. Constraint 1 all the way to constraint 9. Press M, new collection, constraints, enter. So now there we go, our constraints. That's a better way to organize our work, but our work is not done. We need to be able to distinguish between each and every one of them. So selecting this wheel, as you can see, it's in here. It's a collision shape. I'm going to expand that and call it wheel rear L. Wheel collision shape. Wheel collision rear capital L. Control C to copy that. I'm going to select this, paste that. Of course, that becomes R. Wheel collision rear R. Select this, double click, paste that, front. In fact, typically I do FL. That makes it easier. F2 here, RR. F2. RL, and finally double click that. This should be FR. Then now let's select, oh, this should be the chassis. Then we also have the discs. Let's just call it wheel disc. FL, copy that, select that, FR. Now let's go to the constraints, and my seat is sliding down. Yeah, so let's start with this. This is the motor. In fact, let me just keep it consistent. Lowercase, motor, rear, left, or just left. And this is the motor right. Let's also now get this. Suspension, rear right, copy that. Suspension, rear left. Suspension, front right. Oh wait, I made a mistake here. This is front left, and this should be front right. Then of course this is wheel attachment. Wheel to disc. Front right. And here front L, because this is what attaches the wheel to the disc. I think everything is labeled except, we also have steering power, or just power steering. Steering motor L, and steering motor right. So all our constraints are now properly named. The plane can be the ground. There we go. So now let me just select the steering. First of all, I want us to remember the impulse here makes this more or less sensitive. So if we increase this to 5, we'll make this more sensitive. That will allow us to control the car much easier. So I'll select that and give this +1. So that means this other one should be -1. And we want to make sure this impulse is balanced. If this is more sensitive than the other side, it means this wheel will turn a little bit further than that other wheel. But let's make them both 5. And now if we play, it will start going in that direction, right direction. Just like that. Let me now increase, let me select one of the motors here, this, and increase this power. Now we need to increase the friction. Let me just select the wheel and increase the friction to 0.75. And let's also select the ground, 0.75. Let me select this other motor. What's this, the value of this one? Let me give it a power of 5 and this other one 5. Don't worry, in the next lesson I'm going to show you how we can control all these values in one place so you can drive the vehicle around, because right now you can't. All right, so now let's start again. And now this time the car moves faster, it's more responsive, it has more friction with the ground, and thus it's able to move almost physically accurate. Look at that. I think we have ourselves a nice rig that you can use with any type of car. You can always use this system to create rigs for your cars in the future. Now, what happens if we change the steering direction here? Let me select this X. Let me change this to +1. As you can see, we have this problem here. We need a way to control both of them. So how do we do that? Let's see how to do that in the next lesson. Don't go anywhere. Now it's time to create a unified steering system, because right now what we have is not usable. So how do we do that? Let me just bring it to the beginning and pause it. Now, getting closer to the model here, I'm going to Shift A and add a plane, GZ, to push it up slightly, maybe make it slightly smaller. Now, with this plane selected, I'm going to go to its object properties. I want to edit some of its properties. And specifically, I want to create new custom properties, 2 properties, acceleration and steering. We want to be able to accelerate from one spot, because remember we have two motors, 1, 2. So we want to be able to accelerate from one spot, from one value, and steer from one value. So selecting this plane, we'll go here down, create new, and this is a new custom property. We're going to rename it to acceleration. And let's say we want the default value to be yes 1. Minimum value, if you put it at 0, the car will come to a stop when the value is 0. But if you put it at negative, maybe 2 or 3, the car will be able to reverse. So I'll put that at negative 3, maybe positive 10 or 8, let's say 8. And I want to move in steps of 1 when increasing the speed. Yes, I want to move in steps of 1. I think everything is okay there. So I'll go ahead and say that. Now we have acceleration. And what I'm going to do now with this acceleration is right click this, copy as new driver. Then I'll go to the motors. I'll go to this motor constraint, open the constraint itself, and here paste it right here in the target velocity. Remember, this is the value we are controlling to power the motor. So paste here, paste driver. So that tells Blender when we change this value, if we change this value should also be provided to this field. So it's as if we're entering that value, this value indirectly from that other side, from that driver. So because we still have that same driver, we can come here and do the same here, paste driver. And now, as you can see, the value is 1 because here in the properties, it's 1. Now, if we want to see this value, while this is selected, the plane and item is active, here it is. So if I play this, I can slow down the car. All right, now I think we need to let's slow it down by default. Let me just put 1 and let's play. Wait, there's a problem. What's the problem here? Now, acceleration. The problem is the max impulse here. So it's too low. That means the vehicle is not as responsive to my inputs as I want it to be. So if I select this and play, the vehicle is not responding to me. But if I go back here and set it at 5, set this at 5 as well. All right. All right, so now let's try and solve this by balancing these values. I just want us to go back to the beginning, selecting this. Let's make the impulse 10. 10. See if we can have more control over the acceleration. So with this selected, let's just start with 1. Just like that. And now if I increase this gradually, if I slow it down, it now starts reversing. If I push it forward, it starts moving forward. So the issue here is to make sure we go back to the different motors. Let's just increase the maximum impulse to 10. So if you're using the default Blender scale, then these numbers should work for you. Max impulse, how responsive is Blender to our input in here? And of course, you have to make sure it applies to both motors because we want to make sure they're both balanced. All right, now I think we should move on to the front, to the steering. So with this selected, I'll go back to the object properties and add a new property. Do the same. Let's go in here and call this steering. And we want the default value to be 0. In other words, we want the vehicle to move in a straight line unless we decide to sway. So the negative side will be -1 and the maximum will be +1. So 0 is straight, -1 is left, +1 is right. All right, and here I want 1 and 1. Okay. So now we have steering as well. I'm just going to copy that as new driver. And I'll go to this constraint here that powers the steering. Go to its properties. Here in the target velocity, paste driver. I'll do the same for this. Paste driver. Now I notice this has 5, and this has maximum impulse of 5. All right, so now I think we're good to go. Let's test our car, but let me select the plane first. So we have the two values. Acceleration, let's start at 1. Steering, let's start at 0, and let's now play it. Let's steer it left. All right, there's a problem here. I think there's a problem with the positive and negative inputs. We're just freestyling this. How am I going to solve this? Because this expects a negative value and the other one expects a positive value. All right, so what we can do is rotate this to face the front, this Y to face the front, but still keep the X facing down. So rotate it in the Z axis 180 degrees. So the X is still below. Now if I select this, I don't know what's happening here. I need to debug this. All right, now let's rotate it in the Y axis because this is just a matter of what axis it's rotating at. So let's rotate it at the Y axis and see if we're going to solve that problem. Rotate it in the Y 180 degrees. So now they're both facing up. I think now that's a better, now we have a way to control it. All right, I love that. All right, so now let's go ahead and see if we can control it this time. Speed of 2.5. And let's play. Let's move left. No, let's move. All right, now I want, when we move in the negative side, I want it to also turn left, and when we move in the positive side, turn it right. Not like now, because when I move to the positive, that's when it goes left. So what we need to do is go back to the beginning and make these upside down, rotating the Y 180 degrees. So now negative, positive, exactly like that. So negative, positive. Let's increase the speed. Negative, positive. Just like that. I love it. So now I think we're ready to move on to the next step, which is attaching our collision shapes, these collision shapes, to our actual vehicle, the dumper truck. How do we attach this collision shape to our dumper truck? And for some reason, this is attached to that, which gives us a hint of what we're going to be doing. So see you in the next lesson. So now it's time to actually drive our truck or our car model, if you chose to work with a different model. How do we attach it? Essentially, what we want to do is parent the truck model or your car model to the collision shape, so that when the collision shapes move, the truck moves. So we'll start with the chassis. Right click, select all objects in the chassis, and if I hit the / to isolate it, this is what we have selected. / again to exit isolation mode. With that selected, the last item I'm going to select is the chassis of the collision shapes. Just like that. Now, while it's still selected, I'm going to say Control P to parent it. That means we're parenting all the objects selected to the last object selected, which is the collision shape. So object, keep transform. Let's just say object keep transform. That means all those objects will remain exactly where they are in relation to the object they're parented to. They will always be where they are in relation to this. So when this moves, they will move and stay in the same position. So, and in order for this to work, you must make sure you are anywhere here before the simulation starts. That makes sure you're properly aligned right here at the very beginning. So with that, let's just play and see what we have. Now that we have the chassis of the model parented to the chassis of the rigid body. There we go. The truck is already moving. I love that. But now, of course, we have a problem. Our wheels have been left behind. Why? Because we also need to parent the wheels to their rigid body counterparts. So let's go back to the very beginning. And I'm going to come to this wheel. Expand the wheels here. Wheels rear, rear left. I'm just going to right click, select objects, all of them. And then I'm going to come close here and right click and shift click the rigid body wheel collision RL. Then Control P and keep transform. I'll do the same for these. Select all of them. Then select this Control P, keep transform. Let's go to the front. Let's do the front wheels. So front, let's start with front R, select object, then select this, then Control P, object, keep transform, and make sure you don't move these collision objects. If you move them, you will break everything you've worked on. So don't move them from where they were. Like, don't select this and then try to align it by going to the front and trying to align it to the front wheel. Doing that is going to break everything. Your rigid bodies should, or collision shapes, should remain exactly as they were when you created them. So finally, let's go to wheel, front L, select objects, then select the collision shape, Control P, keep transform. And now let's start driving our truck. Let me select this plane. In fact, let me just pause this and rename this plane to our what are we going to control? Vehicle control or controller, because this plane is represented by these two values, acceleration and steering. Remember, we created two new properties for the plane. We can make it even much smaller just to not have that ugly plane there, but I like having it big enough for me to select from any angle. So now when you want to, if you select any other object, it will disappear. If you want to get the controller again, you can select it from here. It will bring this up, or just select the item here and you will be able to see the controller. So now if I play this, let me just go back to the start. So now another thing you will notice is that we can see the collision shapes as well as our vehicle model. We want to see only the vehicle model. So let's select the collision shapes one by one. For example, this one, let's go to its object properties, go down to this viewport display and change this to wire. So now it's just a wire frame. I'll select this collision shape. We're still in the object properties, change this to wire, select this wire and this. So now what we can see is our truck. And if we hit Shift Alt Z, we're going to hide anything that's a wireframe. Shift Alt Z. All right, let me select the controller here. And then let's see if we can move left. Just like that. Another thing you need to notice is that this is only viewport display. We've hidden or made the collision shapes wireframes in viewport display. But if we render this, it's going to show the solid version of the collision shapes. For example, collision shapes. So when you render, it's going to show these solids. So what we want to do is come here. First of all, let me hide that. In the viewport display now, this is what we see. But when we're rendering it, let's go to visibility. Show in renders. We want to make sure the collision shapes are not visible in renders. So disable that. Select that. Let's globally disable in renders. But the physics is still going to be rendered, because they're influencing the children that are parented to them. So these are the children parented to the collision shapes we're hiding from rendering. This one as well, hide them from render. And of course the chassis. One more time. Control S to save that. Now, another thing I want us to do is, you will notice if we play this, our constraints are remaining in place. If you want them to move with the track, you can make them move with the track. I like them moving with the track actually. So let me just hide it first, like that. And I want to parent them to the wheels and the discs. Since this is the suspension, let's attach it to this. Control P, keep transform. Select this and this. Control P, keep transform. Let's also select the other one there. Control P, keep transform. Always make sure you're making these changes with this marker outside the simulation zone. So we have this and this. Control P. I hope it's parented. This and this. There we go. Then we have this and this wheel. Control P. What about this? This and this wheel. Keep transform. Yeah, those are already parented. Keep transform. Let's parent this to the chassis, the motors. Control P. And finally, Control P, keep transform. If we let it move now, everything is moving together with the vehicle. So now if we unhide the track and go back, the only thing you should not move is the controller. It should always remain there. And the reason is because we're controlling everything from the origin or the center of the world. So the controller should remain right there. Everything else is moving in relation to the origin. All right, so selecting the controller and going to the left, just a moment, right there, left. Let's increase the speed to maximum 6. Left. I love it. Now we have a track